So you see problem 2, intro to kinetics, and also want to determine the moment of inertia, mass moment of inertia, about the axis perpendicular to the page, to screen, and passing through the pin at O there. And the thin plate has a hole in its center, and the thickness of this plate is 50 millimeter, and the material has a density rho equal to 50 kilogram per meter cube. So with that, we need to find out the mass first. But as you can see here, find out the mass for this, because they give the density and the dimensions for this one. So we can go ahead to find out the mass. So as you can see, this plate, a thin plate, and have a hole in this case, the circle. So what we want to find out the mass, we find out the mass for the whole full plate, deduct the circle in the center. So with that, let's talk about the mass of the plate. And as you can see, to find out the mass, it equal to the volume times the density. Volume times the density. In this case, the density that they give us is 50 kilogram per meter cube. So we can plug in 50 kilogram per meter cube. And then we find the volume. The volume for the thin plate equal to the area times the thickness. So you can have 1.40 times 1.40, that is meter, that is the area times the thickness is 50 millimeter. So it will be 0.05 meter. And from that we can have 4.9 kilogram. Similarly, we can find out the mass of and this is the whole plate, right? The mass of the whole, and in this case, it's a circle. So the same volume times the density. Density equal to 50 kilogram per cubic meter, and time the circle, the area of the circle, pi r square. So you have it pi time r, in this case 0.150 millimeter, so 0.15 square, time the thickness, the same 0.05, and we have that equal to 0.1767 kilogram. So that is the mass for the plate, full plate, and then the whole. And then we can go ahead to make a table. Unlike the previous problem, which is a little bit more complicated, that we have to find out the center of mass of the composite body. Here, the center of mass, as you can see, the body here is symmetrical, and the center of the plate, also the center of the hole, are the same, and that basically also the center of mass of the composite body. So we already know that, so we don't have to go ahead to find out the center of mass like the previous problem. So let's just go directly to find out the mass moment of inertia about point O. So with that, we can make first is the shape, make the table, section 12, reference data card, IGI, and then we have MI di square, and then we have it IGI plus MI di square, exactly the same that we did in the previous problem. So the unit of here, again, because that is SI unit, so it will be kilogram per meter square, kilogram meter square for the unit, and that one is kilogram meter square. Shape, there are two shapes. The one we consider the thinnest. So let's draw down the thinnest. And in this case, it will be a positive thinnest. And then we have a hole, so we can deduct that circle out. And that will be a negative. So consider the whole thing. Deduct. So exactly the same we do in the centroid. So IGI, where we get the IGI, go to the back inside of the cover of the textbook, here we have the thin disk, and for the hole it's a circular, so it will be a thin circular disk. So those two here. Now they ask us to find out, go through the page. So the axis that we are looking here is IZ, not for the thin disk, not thin plate, right? So not about the X or Y, not X or Y. So as you can see, the equation that we need to do with IZ, so that equation for the thin plate, it will be 112 m a square plus b square. That first thing. And then for the whole circular disc, we will also find out the I go through G and IZ. So that equation, it will be 1/2 of mr squared. So as you can see, depends on the question asked. This question is of the axis through O and perpendicular to the page. With that in mind, so that we have to use IZ for both thin plate and for the circular disc. So with that, we have those two equations. Keep that in mind. So plug it in here. So the first one, for this, we will have 112 m. We already know 4.9. So let's write down the equation first. 112 m m1 time a square plus b square, and plug in the number. It will be 112 4.9. We already find out there, right? And then AB, so the size of the thin plate, 1.4. So you have it 1.4 square plus 1.4 square. And from that, we will have it equal to 1.6 kilogram per meter square. And then for the circular discs, if you recall, it will be IZZ and 1/2 of mr square. We can plug in with that equation. 1/2 of m square is equal to 1/2 of m2 0.1767 times r 0.15 square, and from that number we will get that is 0.00199 kilogram meter square. And md square, what is md square? From the center of mass of the standard shape, so it's here, you have that is G1, G2, to the point that you take moment, to find out the mass moment of inertia, that is point O. So it means it will be equal to mi, so it will be m1 time G1 to O, and this is square, and here, as you can see, it equal to 4.9 kilogram time G1 to O. Where G1 to O? It will be, as you can see, how can we find out the diagonal? It will be G1 to O, also G to O, right? And it equal to 1/2 of square root of 1.4 square plus 1.4 square. So that is equal to 0.99 square. 0.99 meter. So from that, we plug it in here. As you can see, it will be 0.99 square. So we will have that a 4.8 kilogram meter square. Similarly, we have for the circle, it will be the mass. So it also m2 G2O, right, square. So it will be 0.767 times G2O. It's exactly the same because the G2 or G1 also same G. So it will be times 0.99 square. From that we will have 0.173 kilogram meter square. So add the second and the third column, that number. So and this number, we have the last column. So 1.6 plus 4.8, we have 6.4. And keep that in mind, this is negative. So basically the M is negative. So you can be able to put the negative in here because negative. So add those two, it will be negative because that is take out the whole. So it will be equal to negative 0.17. Add these two together, you will have IO go to the pin equal to 6.4 plus minus 1.75 plus minus that. So it will be 6.23 and kilogram per meter square. And that box our answer here. And of course you can do the other way. You can find out the IG and then you apply the parallel axis theorem to find out IO, or you can find IO or find IG first with the table and then we apply IO equal to IG plus MD square parallel axis theorem. Keep that in mind. So with that, we finish the solution for problem 2, intro